So yesterday we began our first unit on transformations, in which we talked about all four different types: a translation, a reflection, a rotation, and a dilation. Today we are only focusing on one type of transformation, and that is a translation or a slide of a point or an image in the coordinate plane. Let's read and answer the problems on the right to determine how point A changes in our coordinate plane as we perform different types of translations. So first, let's identify the original location of point A. So when you're reading your graph, you're always scanning your x-axis and then going up to your y-axis. So point A is at 4, 5 on our coordinate plane. We are at 4 on x, and we are at 5 on y. So its ordered pair is 4, 5. Number 2, if point A were translated 3 units to the right, what would the new coordinates be? If we are moving to the right or to the left, our x value gets affected. It's a horizontal shift. So if we look at point A and move it 3 places to the right, we are now at this location in red. And that point is the point 7, 5. If you notice, since we went 3 to the right, all we really did was add 3 units to our x value to give us the new location of 7, 5. Similarly, in number 3, if point A was translated 3 units to the left, what would the new coordinates be? If we are moving to the left, we are decreasing our x value. So its new location is now at 1, 5. Or another way to look at it is that we are subtracting 3, since we're moving to the left, from our x value. If point A was translated 3 units up, what would be the new coordinates? So remember, if we are moving left or right, our x value gets affected. So if we move up or down, it's our y value that changes. So if we were to take point A and move it 3 units up, we would now be at the point 4, 8. So we are now back to our original x value, and the only thing that changes is the y coordinates. And since we are moving up 3, it's the same as adding 3 to your y coordinate. Similarly, in number 5, if we translate 3 units down, we are taking away 3 or shifting down 3 units on our y-axis. So the new location for shifting down 3 units would be at 4 and 2. So now let's discuss what happened to each x and y value as we moved up and down and left and right. What happened to the x coordinate when we moved 3 units to the right? When we moved 3 units to the right in number 2, the x value increased by that amount. It increased by 3. So conversely, or the opposite of moving to the right 3 would be moving to the left 3 units. So when we move to the left 3 units, the x value decreased by 3. Changes in the y-axis would be the same. If we're moving up 3 units, the y value for that coordinate is increasing by that amount. In this case, it's increasing by 3. And finally, the y coordinate, if we are moving down 3 units, the y value decreases by 3, whatever that amount may be. Let's discuss the different notations that we can have for a translation. So in word form, in the top row, if we are moving 2 units to the right and 3 units up, we would use a capital T to represent a translation, and in our x value, we would show a positive change of 2 since we are moving to the right, and in our y value, we would show a positive change of 3 units up. Similarly, for the coordinate rule, you would show what you are doing to each x and y value. Since we are moving to the right 3, that is the same as moving to the right 2, that's the same as adding 2 to your x coordinate. If you are moving up 3 units, that would be the same as adding 3 to your y value. So the remainder of our table is given to us with certain examples. So in the second row, we're given the proper notation using a capital T for translation. Since we have a -5 in our x value, this would indicate that we are moving to the left 5 units. Since we have a -1 in our y value, this indicates that we are moving down 1 unit. So in word form, we would say that we are moving 5 units to the left and 1 unit down. So in our coordinate rule, we would show what we are doing to each x and y value. So x, we are moving to the left 5, which means we would be subtracting 5. And from y, we are moving down 1, so we would be subtracting 1. In the next example, notice that in the coordinate rule, we are neither adding nor subtracting any value to the x. So if there's no change, the number that represents no change in a transformation is a 0. And if we are adding 2 to our y value, we are moving up by 2 units. So the only change that happens in this example is a vertical shift of 2 units. Similarly, in the last example, 3 units to the left. So if we are only moving to the left, we are not going to be moving up or down at all. So our y value would not be affected in this case. So we are subtracting 3 from every x, and we are leaving the y value alone. You could say that you are doing y plus 0, and if you're adding 0 to a number, you are not changing its value. Let's translate example number 10 together. We are translating triangle ABC 3 units to the right and 5 units down. So each and every point on our triangle needs to be translated that given number of units. So we're going to take point A and we're going to slide it 3 units to the right and 5 units down. We would now be at this location. So don't draw those lines. I'm only drawing them to guide me through the example so that you can see how we're performing this translation, because we want our graph to be nice and neat. So 3 to the right and 5 down would give us A prime at this location. So on the side, I will list for you what the original points are and what the new points are. So our pre-image, or your before, we have A at -3, 9. We have B at -3, 6. And we have C at 2, 6. So our new image, which I will write on the left, so far we've plotted point A prime, and if you were to identify the new location of A prime, we are at 0, 4. So you can count the points on your graph, or you can use the coordinate rule, similar to what we discussed in the table in the previous example. We are adding 3 to every x value and taking away 5 from every y value. So negative 3 plus 3 gives us a 0, and 4 minus 5, 9 minus 5 gives us the 4. So B prime is 3 units away from A, or A prime, which would leave us right here. We would be going 3 to the right and down 5 to get to B prime. And for C, once again, we are moving 3 to the right and down 5 units. Remember to mark your primes, or those apostrophes, over each letter to show that it is the new image. So now we have point B at 0, 1, and point C prime at 5, 1. So if you prefer to write out all the points in your new image and add 3 and subtract 5 to each x and y to get the coordinates for your new image, that's okay too. So from negative 3, 9, we get to 0, 4 by subtracting 5 and adding 3 to x. From B to B prime, we are adding 3 to x, which gives us a 0, and subtracting 5 from 6 to give us 1. Similarly in C, to get to C prime, subtracting or adding 3 to 2 gives us a 5, and subtracting 5 from 6 gives us the 1. For today's classwork, you have to finish the remainder of the station on transformations, specifically translating points in the coordinate plane. And when you finish early, you are to move on to the spiral review station on two-way tables and scientific notation when you have completed your work. Thanks for watching. Ms. B signing out.